Glad you could join us tonight. We have a mix of two videos tonight. We have the tail end of the last one that we had last week with Dr. Jockers and Ari Witten. Unfortunately, as many of you probably realized, we had a power failure and we had 45 minutes on our battery backup and we ran out of power. And even though all our power was out for the whole block that our company is in, so we ended up on UPS power, and at 45 minutes we dropped. So we're going to play the last little bit of Ari Witten, and then we're going to get into the new interview, and that has to do with measurement, and it's Alex Fergus. And Alex and I go back quite a long time ago. My first connection with him was when he did an interview with me in England, and that was 2024, the summer of 2024. So Alex and I go back a ways, and he has been looking at all kinds of different light devices, and there's such a mix mash of specifications that really needs to get honed in on as to what's real and what's not. And we have a lot of technical equipment here that allows us to measure very, very accurately the light in different ways. So we can do that. So we're going to start off with this first one, but I did want to mention that we had connected with the one person who won, or we tried to connect with this one person that was supposed to win, and unfortunately they didn't get back to us. And so for whatever reason, maybe their email went into spam. I have no idea, but we're going to draw a new person, and we will have that for the next webinar. And that's for winning the Palm Ultimate $1,300 device. This is a very good device. I mean, only thing better than that, the Super Palm. But I used this quite extensively over the last week, because last week I had some major dental surgery, and then yesterday once again. So I used this on my face for my jaw, and where there was a lot of work being done on inside. And unfortunately, as a kid, I liked chocolate too much. So that was one of the problems, and it's caught up to me all these years later. So have to get some stuff fixed up, and my face could have been much, much bigger, but I've been using my light to avoid having that swelling and speeding up the healing. And my dentist was extremely pleased with the progress that I'd made. So with that being said, we're just going to do our first little intro video, and then we're going to go right into the last part of the interview with Ari Witten.
15 years back, I realized that light could make a huge difference on the body. I ended up designing this very powerful light using LED technology. With this amount of very high power density, it can reach through the tissues and travel right to the joints. But the key is that the power density and the area is extremely important to deliver that light into that. The mitochondria receives that light and converts that energy into the cell. So it's like giving the cell super high octane fuel, and they run like a jet, and they're able to do all the things for repair in that. What are the products we have? Well, we have a small device, which is actually large when it comes to light therapy. You have a fairly large area of light and a high power density that can be used for different parts of the body, like your fingers, shoulder, back, neck, knees, ankle, anywhere on the body. And then we have what's called the mini canopy, which is about a foot square in size. And then we have our full-size canopy, which is basically 6 of the mini canopies. And then we have another device, which is the helmet, and that device can help for mental issues, for brain injuries, for concussions, for PTSD, TBI, all of those kinds of things. And there's new research out there that shows it could be helpful for not only strokes, but dementia, Alzheimer's, and Parkinson's, and just different brain issues. Our plans are to move this technology into every area of the world where there's pain and inflammation, which is basically everywhere, and to expand that so people understand all the applications where this technology can be used to help them in their health in the body as a wellness device. People are looking for how they can treat themselves without drugs.
All right. So as I mentioned earlier, for those that have just tuned in now, we're just going to go back to the interview that we did last week, the tail end, the last 15 minutes or so of the last one. And because we had that major power failure. And yeah, so it's so good. I want to make sure everybody gets a chance to watch this. And then we'll get into the new video. So this is Dr. Jockers and Ari Witten talking more about light and the body. So here we go.
A lot of people are getting that for hips, for knees, for different joints. And, it's a key part of regenerative medicine. But this is a way of doing it without, injections, without surgeries, a lot of invasive, highly expensive procedures. And so this is something you can be doing at your house. And, a good red light device is going to cost you a little bit of money, but to think that it's actually stimulating stem cells and having effects like that, it's really, really powerful. And that's just one of the many benefits, all the different growth factors like you were talking about. We didn't really go into a lot of detail on things like mitochondrial melatonin, but we're finding that melatonin is not just a sleep hormone, but instead it's it is a sleep hormone, but at the same time, it also has a really profound effect on keeping the mitochondria healthy and functioning well. It's the most powerful antioxidant that the mitochondria produce, and it stimulates all the other mitochondrial antioxidants, catalase, glutathione, peroxidase, superoxide dismutase, and so it keeps the mitochondria healthy. So all of these amazing benefits, like if you were to get if there were a drug or a supplement that could do all the benefits that this sort of photobiomodulation does, I mean, it would be the miracle, in a sense. It would be touted and marketed as the miracle drug or supplement. And yet this is something you can install in your house, right? And obviously we can get it from the sun, right? So if you can't afford it, you can afford to get more time in the sun, more quality time, not get sunburnt, but good quality sun exposure on a regular basis. And that's how you get it for free. Or you can get one of these devices, particularly in the winter months. I know that's when I tend to use it more, is in the winter months when I'm not able to get into the sun as much. But this is profound. This is really powerful.
Yeah, absolutely. You said all the things I wanted to say there.
Great. And of course, in your book, you also go through some of the issues when you're trying to get a good panel. And you mentioned some of that earlier, but there's a lot of different companies out there that are selling red and infrared light panels, devices, whether it's face masks, things like that. What should people be looking for when it comes to these types of devices? What should they be on the lookout for?
Okay, a lot of things to be aware of. So one, let's go back to local versus systemic effects. So let me tie a bow on this topic real quick, and this will segue into panels. So if I'm interested in maximizing a local effect, let's say facial skin anti-aging using a device like this, I'm interested in
a face mask for anybody that's listening online. Yep.
Thank you. So I'm really interested in what are the correct irradiance and dosing parameters for this specific issue I'm trying to address. I want facial anti-aging. Okay, so I want, let's say, 20 milliwatts per square centimeter. I want to dose it at, let's say, 10 minutes. And that's the correct dose for delivering the correct amount of light to these specific target tissues. Now, To the extent I'm interested in those systemic effects that I was mentioning before, the whole body systemic effects, the anti-inflammatory effect, the shifting of the immune system, the potential growth factors and stem cells and all these things now in circulation for sort of more general anti-aging longevity benefits, tissue repair benefits. I want to be looking at the kind of devices that I'm using and the dosing parameters differently than I would if I'm using a face mask specifically on facial anti-aging, or even if I'm using it on some other area. Let's say I'm treating a specific injury on my knee or my elbow or whatever. If I'm interested in systemic effects, I want a much, much bigger total dose of light delivered to my body. And the way to do that more effectively is to use, number one, a larger device, number two, a more powerful device, and number three, this kind of goes with a larger device, but to use it on a much larger area of your body. And if you're doing those things, you can, to give you a sense of it, compared to, let's say, using this face mask on my face, I'm just going to make random numbers up to make it easier to understand. Let's say I deliver a total of, let's say, 50 units of light that I deliver to my face as a result of that, to my whole body as a result of using this face mask for 10 minutes. Well, if I use a large panel, or let's say a whole body pod or something along those lines, something that's shining light over my whole body at a higher intensity, I might deliver 500 or 1,000 times the total amount of light to my entire system relative to what I did with the face mask. So we're not talking about a small effect. It's not 10% or 50%. We're talking about many, many orders of magnitude difference in the total amount of light delivered, of what you can do with a larger device hitting a much larger portion of your body. So if you want those systemic benefits, that's what you need to be shifting towards. So, to a large extent, this depends on what the person's goal is. If you want facial skin anti-aging, you want to prioritize delivering the right dose to those tissues. If you want whole body systemic effects, you want to prioritize maximizing light delivery over the whole body as much as possible with a more powerful device. So that's the first key layer of the story. And this is where panels become much more useful, is delivering those systemic effects to the whole body. Now, unfortunately, the industry is kind of a mess in the sense that, number one, there's lots of junk devices on the market. And number two, it's further contaminated by the fact that lots and lots of companies are just overtly lying and misrepresenting the actual irradiance numbers of their devices. And this is a rampant thing in the industry, and this is part of what I'm trying to do with my new book, is clean up all of these shady practices that are going on in the industry. The gist of it is that
so this is a big challenge that Ari is talking about, is the specifications. They're all over the map, and that's very unfortunate. But I will suggest that people get the red light therapy book that from Ari. We're quoted 10 times in that book for some of the research that we've done. There was more, but he could only put so much in the book. But I was very thankful that Ari had put this book together, and we collaborated on certain parts of information. So definitely have a look at the try and pick up. You can on Amazon. There, I will recommend get it from Ari. Online is red light therapy on Amazon, the ultimate guide. So anyways, let's go back to it. But he's so accurate in how messed up everything is, because there's no honesty out there. And that's unfortunate, or very little.
A lot of companies started claiming that their devices were emitting much, much higher irradiances. Companies started competing with each other as far as who could make the most powerful, highest irradiance panel. And so all these companies kind of became enmeshed in this marketing battle between the brands of who has the most powerful device. Everybody's each 6 months or year trying to make a new generation of device that's more powerful than the last, and also lying about the actual irradiance figures that their device emits. So to give you a sense of this, some devices on the market are claiming they emit 160 or 170 milliwatts per square centimeter. The true figure might be something more like 70 or 80 milliwatts per square centimeter. And that matters not just in the sense that they're lying in terms of the ethics and the integrity, but it also matters in terms of dosing the red light correctly. You need to know what the true intensity is in order to correctly dose it. For other devices, let's say flexible pad style devices, even whole body pods, where companies might be charging $50,000 or $80,000 for some of these crazy big tanning bed style pods. There are issues that have been discovered where some of these companies are claiming 60 milliwatts per square centimeter, and the true number is more like 7 or 10.
Wow.
So not just minor differences, but really significant differences. The same issue is prevalent across the industry.
Okay, just to give you an idea, he said about very low levels, they claim 50 milliwatts and they're down to 7 or whatever. Our device for our mini canopy is north of 100 milliwatts per square centimeter, even at like 2 inches away. So we have a lot of optical power coming out of our devices. And this past week, I had somebody send us an email and they say, dude, are you using a dual chip under the LED? Well, one of the challenges with that is it's another way that you can only put so much power out of an LED die. So we didn't do that. So instead of having 150 dual wave LEDs, we have let's say 150 LEDs of 660 and 160 LEDs of 810. So we have twice as many LEDs right off the bat because we don't mix the two wavelengths together at the same time or have them combined. So we have separate LEDs for each wavelength so we can get maximum power out of our devices, which means maximum penetration, which means maximum effect as well.
With many different types of devices. So what should you look for? Well, number one, if you want the systemic whole body effects, again, a solid, large device that's going to shine light over a large portion of your body, like a large panel, is a great idea. But I would only do business with companies that are providing transparency, that are providing the third-party lab reports showing the true irradiance figures of their device. And that should be listed very prominently on the site, on the sales page. And there are several companies now doing that. So I would only do business with those companies. Again, that's part of what I'm trying to do in my new book is specifically advise people to only buy from those companies that are providing that kind of transparency.
And you have a list in your book, and then you have a kind of I would imagine a more updated and evergreen site, basically a page on your site. Since your book's already published, there are companies now that are coming in and getting that transparency. And so you're keeping that up to date on your website as well, that people can reach that.
Yeah, that's right. I created a separate website specifically to be a companion to this book for device recommendations. And it's called, it's something really generic like redlightdeviceguide.com. That's the site, redlightdeviceguide.com. So if you go there, you can find my specific recommendations for brands that are vetted and that have, the real irradiance figures that are quality devices. In many cases, devices that have actually had clinical trials done on them, so that they're actually supported by research. and have things done the right way. Like, for example, a face mask that has the right LED density, that has the right irradiance, as opposed to the million other face masks that don't.
So redlightdevice.com. Check that out so you can see what
redlightdeviceguide.com.
Redlightdeviceguide.com. So you can check out what Ari is looking at, what has been tested, and you can actually get the right specifications and the best brands to do business with. And if there's anybody listening out there that has their own red light brand, which we do have listeners that are selling these, go ahead and get them tested. And if they're not up to spec, get them remade, right? Remade and make sure that we have as much transparency as possible so people know what they're buying. So that's really going to be the key.
And specifically, if anybody is interested in doing it, there's a lab in Pennsylvania called Light Lab International, and that's the best lab in the country to do it with.
Perfect. That was going to be my next question. Where do they actually get that testing done? So Light Lab International in Pennsylvania.
So yeah, with Light Lab International, we will actually be having his the next discussion we have is with that fellow that runs Red Light, the lab for testing, and we will be doing another independent test of our lights technology, and although that's going to take some time. But we're going to do it. I'm pretty confident because we'd like to once again put it out there that we want to be as accurate with our numbers as possible. So there we go.
Okay, great. Perfect. And so guys, definitely check out the Ultimate Guide to Red Light Therapy that Ari wrote. Phenomenal book. You'll be really inspired to start engaging in using photobiomodulation, red and infrared light. The healing benefits here are really profound. There's just so much benefit this can have for our body. And it's something we've been exposed to throughout the history of mankind in nature, because all of these spectrums of light come from the sun, and our ancestors were in the sun a lot more than we are. And in fact, in our society, it's starting to go away, but many of us have been trained to actually fear the sun. And that's really not the right idea. It's utilizing the sun in a mature and proper way, right? Getting as much good sun exposure without burning, without causing excessive skin damage. That's the key. And then really using these light therapies, that this amazing technology we have, in a way to help stimulate enhanced healing, enhanced anti-aging benefits, all the different things that Ari talked about today. So really profound stuff, guys. Again, the book is called The Ultimate Guide to Red Light Therapy. I'll have a link in the show notes, but you can also find it on Amazon.com as well, in bookstores. So be sure to check that out. Ari, any last words of inspiration here for our audience?
Yeah, the last thing I want to say is, we've spent a lot of this interview talking about the more technical side of this and kind of the technicalities of devices and device selection and how to use them and what makes a good device versus a bad device. What I don't want to get lost in all of this technical discussion is the simple fact of this technology has a lot of profound health benefits for all kinds of different things. I think everybody should have one of these, one, if not many different devices. I've got two right next to me, three right next to me, actually four right next to me. I've got a face mask. I've got this device, which is one of my favorite devices for targeted deep tissue use. This is from a company called SunPowerLED. I've got another prototype device for a device I'm developing for myself that's been in development for a year now. I've got a hair loss helmet because I'm prone to hair loss. So I'm trying to keep as much hair as possible as I get older. And, there are many, and I've got lots of other devices that I've accumulated over the years that I don't use anymore because I have better ones now. And what I don't want to get lost in this discussion is there are so many amazing benefits of this technology, and whether you're interested in just having something on hand for wounds and injuries and aches and pains, whether you're interested in whole body systemic effects, whether it's hair loss or facial skin anti-aging or enhancing athletic performance or body composition, or amplifying the benefits of the exercise you're doing in terms of muscle gain, in terms of fat loss, in terms of hormonal and metabolic effects, whether it's speeding up recovery from exercise, and the list goes on and on and on. I think everybody should have one of these in their home. And, if you want to dig into the science, you can get my book, which goes very deep in the science and the practical side of how to dose them. But whether or not you get my book, what you should do is get a high quality device for sure.
Yeah. Awesome. Yep. Great stuff. Guys, again, the book is The Ultimate Guide to Red Light Therapy. Ari, again, thanks so much for your time, your expertise, and keep doing the great work that you do. Be blessed.
Likewise. Thank you so much. Appreciate it.
All right. So hope you enjoyed that last segment. And it was kind of neat because when he held up his Palm device, which he really likes, that was neat. But also he talks about another device that he's trying out that he's been working on for over a year. I happen to be involved in that one as well. So it's kind of fun that he has been able to do the research on all these different devices, and he now sees the light. So the real light, our light. So anyways, next one we're having up now is the interview between Dr. Jockers and Alex Fergus. And I think you're going to find this very interesting as well. Now, this talks about about how measurements are done. And so it's a more technical, deeper dive into the way things are measured. And it is kind of funny that towards the end, Alex is saying, well, what one measurement should a person be looking at? And the thing is, you really need to know these good 5 measurements to really know what's going on, because the rest don't tell you the story. You need all of those measurements to know what's really coming out of the panel. So it's not like we can just boil it down to one specific thing, like milliwatts per square centimeter, which is the irradiance, the amount of power you get in a certain spot, because and I'll let it go on because it is so well done. Here we go.
You here on this call. I know we've been talking a lot via email, and I know you know a fair few things when it comes to light testing, red light therapy testing in particular. I'm going to start off with a question. It's more for newcomers, someone that doesn't really know much about red light therapy or light. What's the difference between, say, $1,000 red light mask or a panel and, say, a $20 Christmas tree decoration? Both are putting out the same red light. Why do we need to spend hundreds, thousands of dollars on one of these specialized red light therapy devices?
Yeah, well, first of all, thanks, Alex. Appreciate being on the podcast. In my mind, the intention of these therapy devices is to try to recreate the scenario that's been known to cause a positive effect. So you may have a medical positive effect that you're looking for. And so there are clinical studies that are out there that talk about a certain amount of light at certain wavelengths for a certain duration, and they yield a positive effect for people. When you have something that's, as you say, just a $50 colored light, it may or may not recreate those same conditions, but we don't know until we test it. And so I believe the goal of many of your therapeutic devices is to recreate what the conditions were during clinical trials.
Okay, but if both lights, the Christmas decoration and this $1,000 handheld device or panel, if both devices are putting out red light, from a laboratory perspective, from a scientific understanding of what's happening with light, What's different? I mean, why do we have to pay $1,000 for the specialized device? Why can't we just go and use the cheap Amazon, Christmas tree lights and shine them over our face?
So, so the thing is the Christmas tree lights, they may not have the same irradiance or the same power that you have out of the therapeutic device. They may not be at a level that is useful to the body. They may not have the right wavelength that's useful to the body for the desired effect. And in some cases, just with a red Christmas tree light, it may not have enough power to even cause any effect. We need something that's going to give you the right amount, that's going to be maximally effective and have the best chance of giving you a positive therapeutic result.
Okay, so it's wavelength, which is the precise color that's been emitted from the light, and then power. So you mentioned irradiance. So obviously you're testing these, your lab, these are two metrics your lab tests. When a company sends you a device, what other things are you testing? Is it just these two?
Well, we can test for a lot of different quantities. The wavelength and the irradiance are important functions of those, and there are a lot of different ways of looking at them. A lot of the different ways of evaluating irradiance and wavelength has to do with how the device will actually deliver light energy to your skin. In some cases, you have a product that's meant to be put right up against the skin. In some cases, you have a product that's meant to be some distance away, or it immerses you in light. And so in most of the cases, what we're doing is we're trying to measure what the person that's using this device will actually receive at their skin, and evaluate the wavelength, the balance of different wavelengths, and the amount of irradiance that you have at specific points, also across the entire person, looking at things like uniformity. Are there hot spots in there? Are there places where there's more red and less infrared? Are there places where it's the opposite is true? So when we look at these, we have to look at what is the actual application and have a way of testing the product for those particular, for that particular application.
Yeah, it's crazy. I hope everyone listening can see why, when it comes to reviewing, I get overwhelmed sometimes because there are so many measurements and metrics. Let's say a company claims that their device is emitting 100 milliwatts over centimeters squared. But what does it mean in plain English?
Okay, yeah. So irradiance is a measurement of radiant power that's incident on an area. If you take that to the limit case, that is when you look at the density of the power that's on that surface, you can look for the average irradiance. That tells you how many watts or how many milliwatts are incident on a surface of a certain size. Usually in this field, we measure it in milliwatts per square centimeter. So what we're saying is there's a certain amount of power that would be milliwatts, and this is radiant power. So we're talking about photons, which photons of a certain wavelength carry a certain amount of power with them. You have a certain amount of photons falling on this area. That tells you how much power is landing on that particular area. One more thing that we should mention with respect to irradiance is that irradiance by itself, you need to bound it by a certain wavelength range. So you could say, how much irradiance do we have in the red portion of the spectrum, which is roughly like 600 to 700 nanometers, or how much irradiance do we have in the infrared range?
Yeah, and from it's a good point, the wavelength side, because from a photobiomodulation.
Okay, so a couple of things here is that they talk about the different wavelengths. A lot of panels, they're very, very used to the fact that a lot of panels will mix the different wavelengths together. And so they'll add some blue to it. And wherever they add blue, it's missing red and near infrared. So it becomes very spotty the light output. That again is why we don't mix the two. Well, we want 100% of the wavelength at, let's say, 660, and then you switch it to the 810 nanometer. We do 100% of the 810. We do as much power as we possibly can at the wavelength that you select. So that means we have a lot more, well, we have double the LEDs, or at least, and sometimes anywhere from 5 to 10 times the LEDs that other people have. And that's because we have a very, very power dense field of light that's coming off our device, and that everything is overlapping. So we have very uniform. But that's one thing. And when they don't get into in this one as well, it's not clear enough. But the other thing is that as you increase the power density, and you have a significant enough of area, so let's say a 4-inch by 4-inch area at least, where let's say our panel is 12 inches by 12 inches, thereabouts. You have a lot deeper penetration because of the scattering going into the tissue. So the fact that there's a very power dense array of LEDs, you are helping to get the energy much deeper than if it was a much smaller source. So even even comparing, let's say, our Palm Ultimate or Super Palm is got a 3-inch diameter. That's already a decent diameter or decent area where the light comes off very, very evenly over that whole area. But if we went to the mini canopy, which is like 12 of the 12 times the power of the Palm units, and 15 times the area, we are getting much deeper still because there's more area coming from the mini canopy than the Palm.
Modulation point of view, we're looking at the red and the near infrared and the short range near infrared. So say 600 nanometers to maybe 1100 nanometer range. But Irradiance, yeah, it's a measurement, and you're right. Like, you've got a lot of devices or panels now that have blue light in them, or green, or amber, or they're pushing the near infrared out even further. So one could take a measurement and get quite a high figure because it's looking at all of these other wavelengths, like blue, for instance. If there's a lot of high-powered blue in there, it's going to produce a much higher radiance figure. But then that doesn't mean that panel is going to be very, very good, an exceptionally high-powered red light therapy or photobiomodulation panel, because a lot of the light is coming in that blue range. I do actually want to unpack that a little bit, because I mentioned 100 milliwatts over centimeter squared because it's a common number you see with a lot of companies, especially new companies like sort of entering the space, or 100 plus even. But then a lot of these companies are using what are called solar meters to test the irradiance. What does that mean? What's a solar meter? What are your thoughts on solar meter readings for photobiomodulation devices? And do you use solar meters if a company sends a red light therapy panel to you?
Right. Okay. So solar meter is a type of broadband irradiance meter. The ideal version of that is that it covers a broad region of the spectrum. That is, it covers a certain area of the spectrum. For instance, the red and infrared region. Solar meters are very broad in that they cover loosely the solar spectrum, which is quite broad. It goes from the UV out to the infrared. One of the characteristics of a good irradiance meter or broadband irradiance meter is that it does the job of counting a certain amount of power, or the amount of power that's incident on the detector over a broad region of the spectrum. And that broad region of the spectrum, if it's an ideal irradiance meter or broadband irradiance meter, it will measure nothing that's outside of its range. And when it's inside of its range, it measures a flat response, a flat calibrated response, so that 100 milliwatts per square centimeter that's in the blue would measure 100 on the meter, and 100 milliwatts per square centimeters that's on the in the infrared would also measure 100 milliwatts per square centimeter. This is a what's called this uniformity, or the goal of that uniformity in there creates a phenomenon called spectral mismatch error. If it's not flat, you can potentially have spectral mismatch error. And the spectral mismatch error means that it doesn't respond uniformly to the light output as a function of spectrum. Many solar meters are sort of assuming that there's a solar spectrum to it. They don't have really, they oftentimes, especially if they're not a very expensive one, don't have a very flat response across the spectrum. And then they're calibrated usually with an incandescent lamp to a known value. And then, so that means that if you have something that's infrared, a lot of times they respond much higher to the infrared than they would to the red values. And the average might be consistent, but the problem is that you have this problem of you've calibrated with an incandescent lamp. You're now illuminating it with LEDs. They have different spectra, and your response isn't flat. So your values are all over the place.
Okay, so is it fair to say then, if someone sees an Irradiance figure published for a red light therapy device that has been tested using a solar meter, that one should dismiss the figure, not read into it too much? Or, I mean, like, is it junk, I guess? Or is that too harsh?
I would certainly have a lot of questions about it. And it's going to depend, this.
Yeah, so at this point, they're talking about the solar meters, using solar meters. Again, that's a very, very low cost measurement device. And really, there's not a lot, it doesn't give you a lot of useful information. And it's only one part, like I said, of 5 different measurements. So, yeah, I highly wouldn't recommend somebody who's only got the money to buy a solar meter and compare their panels with a solar meter. That's not a good idea. So highly don't recommend that. Yeah, and the other measurements are so very, very critical when it comes to knowing the real parts of the panel and how well it works. So there you go, a little more information, but definitely we've got some very high-end testing equipment like Mike has. And I've actually had a chance to have a conversation with Mike, and he's going to do, we've had a third-party evaluation before, and we're going to do another one now again. And I spoke to Mike at length, and we're on the same page. We've measured the same things. We compared notes. He's bang on with his understanding as far as measurements go. But the thing about us is we've been able to be very deep in what the lights can do for all kinds of conditions. So here we go again.
In laboratory measurements, we talk about uncertainty levels, which talks about what's the probability that the values that you have are going to be constrained by a certain amount. So what you might call error, or knowing the error in a measurement. When you use a solar meter in challenging environments, which would be something that's really close to a large panel, or when you use it to measure something that's, for instance, in the infrared range, these are all going to challenge solar meters and increase the uncertainty to very large values. So yes, I would be very suspicious of measurements that are taken in close proximity to devices that are using something other than an incandescent source. I think that would be two areas where you would see some very large uncertainties from using a solar meter.
Is an irradiance figure a number? If you were shopping, you know, obviously a fair amount about red light therapy and light testing and light and how it works. If you were shopping for a red light therapy device, a panel, what sort of numbers are you looking out for, and how would you like these numbers to be tested, to be measured?
So I would say one thing that I would like to see is that there's a good, a well-calibrated meter that has I would like to see that it's a spectral irradiance meter. What that means is we've been talking about broadband irradiance meters, which measure all of the power within a certain spectral wavelength range. But a spectral irradiance meter measures the irradiance at each, for instance, nanometer for each very small step in wavelength. So you would get a specific value for the amount of power at each wavelength going from the bottom end of the meter all the way up to the top end of the meter. And then you can integrate it together by summing all those values into the total, or you could take a section of it and measure those. But the good part about that is when a spectral irradiance meter is calibrated, it's calibrated for each wavelength, which means you don't have that spectral mismatch problem that we talked about, or it greatly reduces it.
Yeah, so we do have one of those devices. Just the device alone, you know, general public is not going to go out and buy one of these devices, but it's over $5,000 just for the spectral irradiance meter, you know, where we can look at every wavelength and how much power is coming out for that specific wavelength. But also with that device, you need an integrating sphere, which is a round ball, and he's going to show it here coming up. It's a round ball that's very reflective, and so you can put your light device, shine it into this ball, and mine is about 2.5 feet in diameter. His is larger yet, where you can put larger devices, a whole panel, like a large panel inside his unit. But that's a way that you can hook this specialized meter that connects to your computer, so you can look at every wavelength, and you can get a total amount of optical power coming from the device. So that's really, really key to knowing what's coming out of the device, and then how much area does it cover. You can do calculations that way and know beyond a shadow of doubt what you're getting. But that integrating sphere alone is the one I have, is like almost $10,000 to measure that. So you got quite a bit of money stacking up by the time you buy all of the proper equipment for light measurement. And yeah, so there we go.
Yeah, I know there's some people in this space who they're not bad-mouthing irradiance, but they're saying, no, that's like an historic measurement, you know, we shouldn't be using that now. We should be looking at total radiant flux. Is that the right term?
Yeah, radiant flux or radiant power, yes.
Okay, so briefly explain to the audience what that is, how it's measured, and the pros and cons of that, a radiant flux figure versus an irradiance figure.
Yeah, so radiant flux is just talking about how much or how many photons or how much power is emanating from a source. So you can have the total amount of radiant flux says how much total power, or how much power as a result of all the photons that are coming out of this source in all directions. You can limit that in a certain direction and say, okay, how much are in a certain angular range coming out of here? So you can talk about radiant flux confined within a certain area, and so that is an accurate measurement. But usually when we're talking about radiant flux and talking about total radiant flux, we're talking about how much is coming out of it totally. And if we're talking about that, the measurement is made using a piece of equipment called an integrating sphere. In this, the idea is you have a large hollow ball that's coated on the inside with a very, usually a high reflectance, very diffuse coating that's also spectrally flat. So it looks like a very white, very flat white painted inside of a sphere. You put the source inside of there, and the idea is that all of the light, all the photons that are coming out in all directions kind of bounce around inside of the sphere. It obscures the focus of the beam and just turns it into a just general illumination of the sphere. And then you attach a spectroradiometer up to the side of it, and the spectroradiometer is calibrated for the throughput of the sphere, and you get a total, essentially instantaneous measurement of all of the light that's coming out in all directions, not weighted by its concentration or its beam forming ability. So that's a way of saying how much I'm going to put this big net around this device, and I'm going to capture all the photons that are coming out and measure them as a total quantity of, in this case, we're measuring radiant flux. So we're measuring it in watts or milliwatts total output.
Okay, so high level stuff, then why not just use that figure? I mean, isn't that going to say whether a panel is more, look, as I asked this, I already know some issues with it. The issue with this is it doesn't account for those hotspots. You have no idea if the power is being delivered evenly. You're also only getting total power output, so you have no idea what's being delivered to the skin at 3 inches or 6 inches or 12 inches, right? Like, there's no way to determine that, is there?
No, not from the total power unless you constrict it or restrict it by a certain angular range. And then you can start to make some evaluations of it. But with the integrating sphere measurements and the radiant power, you could have a lot of power, but maybe only half of that power is incident on the target that you're looking for. This is something that as you move farther away, the target area becomes a smaller angle. So you have it kind of blowing past the person that's perhaps right in front of the panel.
Right, yeah. So it's more applicable for a device that's used on the skin, a contact device, because you can assume that all of that light is being delivered to the skin, right? Whereas if it's off the skin, off the body, 6 inches, 12 inches, yeah, like you said, that light's spreading. And then, am I right here, taking me back to my physics class many years ago, this power figure in watts doesn't have an area component attached to it, right? Is that correct?
That's right, yeah.
Whereas the irradiance figure we were talking about before, that was over centimeter squared. So that was power delivered in a particular area. So then the total power output for you, like if you have an irradiance figure and for this particular area you're getting 100 milliwatts, you could then extrapolate that based on the size of the device. You could say, okay, well, a larger panel is in theory going to be putting out more power given it's a larger panel compared to a panel that's also putting out 100 milliwatts, but it's a much smaller panel. Whereas this power figure, you get one number, which is valuable, but it's still not the perfect number that a consumer or a user can draw upon, I guess, to make an informed decision as to what's right or what's wrong. Am I right on this? Is my understanding correct?
Yeah, you're right. These are all pieces of the puzzle, right? Yeah, and it's going to come down to the total amount of power and as you mentioned, if you're right up against the skin, I actually recommend that as a good way of measuring it, because one of the problems you have is if you take an irradiance meter, whether it's a spectral irradiance meter or a broadband irradiance meter, and you put it right up against an LED, you're challenging that detector, or you're using that irradiance meter in a way that it was not intended to be used, and also in a way that's not tied back to the way that it's calibrated.
Right.
So you may be doing, you may be getting some, we're back to the uncertainty discussion. Your uncertainty gets very high when you start taking that irradiance meter and putting it right up against it. But the point that you made is every bit of that power that's coming out of that device, if it's pushed right up against your skin, every milliwatt that comes out of this is going to be incident on your skin if you push it right up against it. And the area that it's pushed right up against your skin is the emitter opening, or the opening of that device, right? So you can now say the total watts that I've measured in that integrating sphere over that area of that emitter is now going to be the average irradiance right up against the face of it.
Got it. Yeah, makes sense. All right. So pretty much there's different tools, different measuring tools for different objectives. And then there's different measurements, different figures for different products. But yeah, it really boils down to the product or the device and how you use it, right? But then in an ideal situation, you get both metrics. You use the integrating sphere, you use the irradiance spectrometer meter, and you get all the data points. So then you can go away and be like, well, we know this is the total power output. This is what's happening at 6 inches. This is what's happening with the light 12 inches and how it spreads out. The problem with that, though, is you get a lot of data points and it's very, very overwhelming. So, I mean, could you simplify it and have, I'm not going to ask this question. I will mention, side little off topic here a little bit here. I'm working on an updated 2026 panel comparison, right? And I want to get it right. So I've been working with Mike here, and we're trying to figure out a way that we can test these panels in a fair way that measures what we're trying to achieve as an end user. So maybe what we'll do when we have uncovered that and figured something out, maybe we can do a follow-up call and explain what we're testing, why we're testing, how it's going to be tested, the pros and cons and limitations. Because I feel like right now, there is no 1, 2, even 3 metrics that one could just use to be like, this is better than that. Well, maybe you get to 3 and you could sort of come up with a few things. What would you rank then, just real quickly, in terms of if you could only choose 3 or 4 readings, and let's focus on a panel. What would you look for? Average irradiance, total power, uniformity? What do you think is important?
I think it's very important. Of course, people are very interested in irradiance, and I think rightly so. I would take things back to early on in our discussion when we were talking about trying to recreate the conditions of studies that show that it has positive effect. That's where I would go back to, is I would go back to say, I'm looking for a certain effect out of my treatment. And so I found a study that shows that a certain level of irradiance for a certain amount of time at a certain wavelength is effective and shows statistical application toward a therapeutic effect. So that then defines my goal. I want a certain amount of irradiance. I want to use it for a certain amount of time, and I would like to have it have the certain wavelength ranges involved in it. In order to do that, I think it's a good idea to look at a grid of measurements on a plane at a given distance. So if you apply this panel at a certain distance, you're going to get a certain irradiance. It's going to be uniform over the size of my body, or my target area. And then I will know from the study how long I should apply it. And then the next part is you want to evaluate the spectral content of it. Where are the peak wavelengths? What does that look like? And so I think that's a case where the integrating sphere is a good idea to take a measurement there, because you can look at the total output and you can balance the total amount of power in the infrared, the total amount of power in the red. You can also look at the grid measurements to look at how uniform that is across that useful area. So those would be my key areas. Would be look at the integrating sphere results for the spectral power distribution and the total balance between red and infrared. And then I would look to the grid measurements for uniformity and the average irradiance.
Okay, cool. So we've got a uniformity reading. You have an irradiance, and then you have the integrating sphere, which shows you the total power, the radiant flux, but it's also showing you what wavelengths are being emitted, and then how much power is going to each of those wavelengths. Is that right? Yeah. Okay. Okay, cool. No, that's good. And hopefully for the end user, the people watching this, they have a bit more clarity and insight. Look, I'll finish with this. Maybe a quick fire sort of question. What's one thing someone should know about when they're buying a red light therapy panel in terms of these light measurement numbers?
Yeah, we talk a lot about how there's so many measurements that we can take, and there certainly are. To boil all that down into just one number, I think is too much oversimplification. I mean, it's easier to deal with when you look at just one number, but I think if you're seeing data from someone, and they don't give a whole lot of information about how they took the measurement, and they just have an irradiance measurement and that's it, I would be suspicious of that. I think the complexity of the geometry of what we're trying to do demands that there's a little bit more nuance to it. So I would look for a little bit more information. Maybe they have it and they're trying not to confuse the end user. I can appreciate that. But if you ask them for more information and they don't have it, that's a red flag to me.
I like it. Mike, thank you so much for taking the time. I'm sure there's going to be a lot of questions. I know I've still got a lot of questions here, so maybe we could do a round 2 in the coming months. And, once this is up, if people have questions, leave them below and I can work that into the next podcast.
Really appreciate you having me on here, Alex. This has been fun.
Cool. No, likewise. All right. Well, thank you so much. And until we speak again, enjoy your day and thanks. And that is a wrap. I hope you enjoyed it. If you do have any...
All right. So we're just getting there. All right. So I just want to show you, this is our setup here. And you can see there's the integrating sphere. There's other meters. We were just in the process of doing some measurements there. But that ball that you see there is like 10 grand. The meter just to the bottom there is about $3,000. The little black box to the left, that's about $5,000. So yeah, there's a lot of cost involved in proper measurements. And you also have to understand what you're measuring. You just can't buy some equipment and say, hey, there it is. It's sitting there. No, I have the measurements that we know what we're talking about. So now I'm going to get into some questions here. Kay is asking, I want to treat inflammation in my abdomen. It's for microbiome issues as well as core strength. What are your experiences and recommended times? My suggestion, if you do have the Palm Ultimate or the Super Palm, you can place that on your belly. And yes, we've had some people that have explained that they've had issues with different challenges like Crohn's or colitis, and they've had improvement. There's also, you're helping the microbiome, and there's all kinds of neat things there. But just want to say yes. You probably want to go for the ultimate or the super pump because you want a little more power to get in a little deeper. So hopefully that answers your question. Okay, let's see. Rossi is asking about a friend who has dementia. Yeah, for 35. Oh, you've known him for quite, just got dementia. So yeah, I have a webinar going back on my YouTube channel. It's easy enough to find on YouTube. Is a fellow with Lewy body dementia that it really helped him as well. Mary, I think, is the different spelling, but which super palm device would you suggest for broad treatments for our family? Treatments would include experimental help with seizures, and I'll just skip a little bit there, and helps with aches and pains that my husband and I are late 60s, 70s to deal with. I don't know about this age thing of 60s, 70s. You start having a little bit of dental challenges or more severe dental challenges. You have other aches and pains in your body, but it's not limited to those in the 60s and 70s, with 60s and 70s. Yeah, it's just one of those things. As we grow older, our bodies don't quite work as well as they were first designed to be. I think we would do a whole lot better if our food source was much better than it is right now after all the processing, after you find out all the chemicals that they've used in the processing, after you find out all the sprays that have been used, chemicals and you name it, that's happened. And then you put somebody indoors and they're blocked off from all the near infrared light and they don't get the proper balance of different wavelengths. All of those things are not good. So one good thing is to definitely there's a good trending out there on how one would go out in the sun first thing in the morning. And the crazy thing is, I just heard some type of study that was done where they found out that, okay, seed oils, if you have certain proper oils in your body, you don't have problems with sunburn. And, as you get into the sun more often, you'll do better. But another one is somebody just mentioned that to me that apparently our eyes, if you wear sunglasses, you are actually not allowing your eye to see the amount of light in its context. And the eyes actually help you to avoid sunburning because it causes other stimulus. Now, I'm going to find out where that information is, but it's pretty cool. So those that wear sunglasses have a higher chance of burning. And you need UV ultraviolet B on the rest of your body. You need a small amount of UVA, and you need that near infrared wavelengths that come into your eye that can help the eye. But I'll just mention here. So, Mary, that's a long answer to your question, by the way. But when it comes to whether using the ultimate or the super palm, because of depth and other things like you mentioned about the seizures, I would still recommend the ultimate or the super palm, either one of those. And yeah, we've seen beautiful, beautiful results with seizures as far as the lessening of the seizures. And I do have a webinar of a young girl was 7 years old that she went from 10 to 15 seizures a day down after immediately following using the first helmet treatment, which he was using daily. She was down to one seizure a day with using one treatment a day at 30 seconds red and 1 minute near infrared. And then later on, I asked her to double up the treatments, asked the mother, and the mother decided to do that. And she was down to one seizure every 4 to 5 days on average. So really, really neat how light helped with the seizures for that. Douglas says, how much does it cost to get the full size panel? Well, the full size panel is the mini 6 of the mini canopies. So the mini canopy is like $5,900, and 6 of those kind of thing. But we're looking at about 35,000. The mini, and it has a full stand, up and down stand. It has all kinds of stuff. So yeah, and there was another question that had come up about FDA. We are FDA registered, and that means that we have a quality control system that we're using to as we build these lights. Or we're not getting them shipped in from overseas, built in China. It's all built in North America, and we go through and handle every last one of these devices and make sure it's working properly with all the proper measurements to make sure what we've got going out the door is what we have on our website. So we know that we want to make sure we give out the best quality that we have. Now, there's a question here about the warranty. We have 1 year warranty on our professional and ultimate, and then if you go to the Super Palm or the mini canopy or the helmet, it's 2 year warranty. And we like to make sure that the units last a long time. And Jesse, in answer to your question, how many hours do the lights last? Well, one of the things with LEDs that light the cities and are, all these kinds of things, if they're treated right, you can get 50,000 hours out of them, and it only drops 10% of light output power. And the reason we believe now, who has been around for 50,000 hours? Nobody has. But the way they can figure that out is the hotter that they make the temperature that the LED is cooling to, the shorter the life. So that's how they do accelerated light testing to see how long it is. So the hotter, anytime you heat electronics hotter, it has a shorter life. And what we've done is, instead of running our LEDs at like 80 degrees Celsius, like what they're rated for 50,000 hours. Remember, 50,000 hours that'd be like using it for 2,000 hours a year for 25 years. So no, these LEDs are not running even at 80 degrees C. They're running at 45 degrees C. So we have happy LEDs on our devices because they run cooler. So, and that gives us a much longer life, as well as we don't, there's no flicker to this because we're running DC unless a person wants to get into pulsing. And so, yeah, this is a very long time these units can run. Now, the only time that the life can be really, really short, if it drops out of your car and you run over it, that's going to be a very short life. We can't do anything about that. But when it comes to using it properly every day, it should last you an extremely long time. Okay. Okay, good. I like this question. Douglas, what is the advantage of using NIR separate from the red wavelengths? Why not together like other products? Yeah, a lot of products put them together. What they do is they put a red LED here and a near infrared LED here, and then another red and another red and near infrared, and they'll mix them. You're fixed to, so if they're fixed to whatever they designed in it. So if they use 40% red and 60% near infrared, that's what you're going to get, and you're stuck with it. The thing that we do is we allow you to do all of the red 100% or all of the near infrared at 100%, so that you can't crank up the power anymore, or you'll start getting hot. Okay. As a matter of fact, when you get down to the 660 nanometer wavelength, it is pretty warm on the skin. So you can't push it anymore. But I want as much as I can. The other thing is that you can buy an LED, a single LED, a powerful LED. But what they do to make 4 wavelengths is they make the chip size very small. So let's say RGB, red, green, blue, and they may even have a specialized white on there, or another color if they want, near infrared, let's say. But the problem is then that LED is just the part that emits the light is 1/4 of the size of the LEDs, the LED die that we have. So the LED die runs cooler. We can drive it much more, so we can get more energy coming out of that single LED. But it costs a lot more because we're using twice the number of components to at least to offer 2 different wavelengths. But we want to be able to use, let's say, 1 minute of red and 3 minutes of near infrared, or 1 minute of red and 1 minute of near infrared. We want to have that option so a person can control the dose on the wavelength that they want, specifically for their condition. So let's say treatments of a hand, you would use 1 minute of the red wavelength, let's say arthritis in the hand. Look at the penetration that's getting. It's going right through my hand right now. So that's 1 minute of the red. And then if we switch that with the near infrared, although you don't see it coming through my hand, there's far more coming through my hand right now, anywhere from 10 to 20 times more is coming through my hand right now with the near infrared wavelength. So we do 1 minute, 1 minute. But if you're trying to treat your hip, you got to go considerable depth into tissue. So you've got to go to, to get to the joint. You're going to spend a lot more time with the near infrared. And so you may spend 3-4 times more time with the powerful near infrared and some time with the red. And we do explain that on some of the other webinars because we like to have the red. We still want the red, even though it doesn't penetrate as deep, because we want to get the blood flowing. There's the blood absorbs it. It's also a systemic effect. Hey, I like that very much, Steve. Is it better to have 2 palm devices and use it as a sandwich for treating your knee or shoulder? I do that a lot when we're out on the field because it does it so nice and fast. I think it gets us even faster results. It's very, very hard because we're not in a controlled situation when we are when we're at a medical show of some kind, because we get every kind of every type of device, people having different problems. So we can't say we got it control, but I mean, we've done that with a mini canopy. We'll have somebody at a show and we'll put the mini canopy on their back shoulder area. And then specifically they'll treat from a spot on the front where they also feel it. And wow, beautiful, beautiful, results. And I have videos that are posted. Please go to our to the YouTube channel and look up SunPowerLED. And we've got a whole pile of shorts there of different people that we've been treating. So yeah, I think you would find that very interesting. And by the way, when you're there, please remember to like and subscribe our for our videos, because that helps us get out there. More people that get to learn about this, the more we can do. So, yeah, let's see. Marlene, I have a two-part question, but before I ask, I like to say that was a lot of information that obviously I don't truly understand. I'm sorry, but some people in our group do really want to know, and I just want to point out that these guys were quite accurate in most of what they said. There's a couple little parts that I disagreed with a little bit, but for general, they did extremely well. And I thought you guys need to hear it from somebody else other than myself. So that's why, and I think there's a lot of good information there. So, anyways, however, it is why I'm grateful for a company that is honest and transparent that we can trust. So my question, when I put the palm in a specific area right up against the skin, I imagine I'm getting full irradiance, the max power, but if I move it a little away, am I losing full benefit? As a matter of fact, that's a really good question, Marlene. And let me just show you an example, what you just said. So if I turn it on like this, I might be able to show it on another people. Let's try this again. Another piece of paper here. So if I put it on here like this, you see from the backside, you can see that there's a little bit of spray there. But as I pull back, come on. It's a little hard to do these demonstrations. Okay. So as I pull back, you can see the area gets bigger. But what doesn't happen is the power is not lost. So if I go with an area like this, and I've got 5 watts of optical power, or 6, 7 watts of optical power, and I expand it, and I'm back a little distance away, I'm still getting 6, 7 watts. What I'm not getting is it's not taking off away from my body, generally speaking. Unless I'm treating my hand, then obviously as I pull it back this far, I'm going to start missing my hand. So what happens is that light that's still coming out a little larger is not lost, and it's scattering towards this to all directions. So it actually does still help in penetration. So it's still going deeper, but there's a little bit of depth lost, but you're covering a larger area. Okay, so that's what happens. I designed this product with those bumps on there. You see those bumps? That's so that you can get some little bit of airflow, so you can still cool your skin with those bumps on there, and still keep it real close. And at the level of the bumps, that's as close as you need to get to have the irradiance that we have coming from our devices. So that's what we've figured on. But if you were to pull it back a little bit, all you'd just be losing a little bit of the depth, not the power. Laura's asking, do you have a guide for the times of applications of different circumstances or issues? Yes, that is correct. We do have a guide that we have that when people buy it, we didn't have it we didn't have it in the earlier days, but we do have a guide that gives you an idea. If yes, okay, so here's another one. Susan is saying, I've noticed an increase in heat if too close for a long time. Yeah, and it depends. Some people could put up with this for 20 minutes, and others will find it too warm. So it really depends on the person, their skin tone, and some other factors that affect how much warmth that they feel on the skin. So if it is a little too warm, two things can happen, or a few things can happen. You can move it, keep moving it, do a little while, do it there, do it there, do it there. I'm just using my face as an example, as I use that extensively because of my dental surgery that I had. And and I have very little inflammation, even though yesterday I had some major work done on that, on a major part of the gum line and all that stuff. So I was able to use it and help it right away. And the dentist, as well as the assistant, had said, you should expect that you're going to get quite a bit of swelling from all the work that was done. And I really didn't. There was just a little bit of swelling on that side. And last week I had even made more major work done. And yes, I did have some swelling, but I kept it down. I also have the other device that I have as well. So yeah, you could move it around. That's one way. You could pull it back a little bit to do a little larger area. So your power density is going to be a little bit better. Yeah, yeah. Deborah, you were asking. I felt I was in oral prison, vocal prison, for a few days. I was not supposed to talk. That was pretty hard to do. So I was not supposed to talk and limit my talking to a minute or two max. That's near impossible for a guy like me. So, anyways. Um, Carol is asking, with the Super Palm, how long are you doing the red, and how long are you doing the near infrared? Do you open your mouth? Good point. So you've just had dental work done as well. So I'll tell you what I did. What I've learned along the way is that for pain and inflammation, usually they tell you do icing, but there's new learning that is also coming out saying about how icing actually slows down some of the metabolic process. So you're trying to heal that area. So why not keep it going, keep the process going full tilt? And if it does cause a little bit of swelling, well, maybe there's some inflammation required to skip to boost the thing into full gear. But in my case, I used it on the outside here, and I would do 2-3 minutes of the red and then switch it to the near infrared and do like 10 minutes. Now that's far more than that was far more than what the minimum amount of time that you'd need to get results. But I wanted to have, keep the inflammation down. And as it would turn out, even though I was prescribed some painkillers for the work, I did not need to take any painkillers at all. I mean, when it started getting a little bit, I'd use the light on it and come down. It was tolerable. Yeah. So Douglas is asking, did you mention the announce for July winner? Yeah, Douglas. Yeah, right in the beginning, I mentioned that the person that we tried to contact would not contact us back. We think that maybe they went away, or maybe somehow they made a mistake in their email when they signed up, but we couldn't get back to them. So we're choosing next week. We will announce July's winner. So yeah. What health issues are treated better with the 810 nanometer, and which are treated with what are better treated with the 1050? Generally, the 810 and the 1050, very good questions there. The difference between the two is the 1050 is definitely a longer wavelength. And so there's a possibility of it happening. Okay, so 1050 does have the possibility of penetrating a bit deeper, but it also there's more research that needs to be done on the when it comes to the structured water that can be caused, and that some people still think that doesn't exist, and yet there's more and more research coming out that there's this fourth phase of water that people don't understand anything about. So Susan is asking, why 7 minutes for the migraines? Does it matter what part of the head? Well, usually what we found is we were just at a event with a Christian music festival, and there was 40,000 people that were there. And we actually put it up on the big screen when they had the concert about the fact that we were doing helping people with migraines, and we had 12 people come out to try it for migraines. And we saw 11 people significantly improve their migraine situation, or some had a couple bad headaches. Well, it was extremely loud music too, so they weren't doing any favors to themselves, but really beautiful results. We do have that now posted on our YouTube channel, but so 11 out of 12 that we improved. Now we found, so this is the red wavelength right now, and then this is the near infrared of 810, or if you have a super helmet, it has the 1050. What we found is that with migraines or really bad headaches, we need to have about 6 to 10 minutes of time under the helmet. And the one person that didn't respond, she was under the helmet for 3 minutes, and we had just finished telling about so what we ended up doing is I told her, usually we do 6 to 10 minutes. And usually we do like 2 minutes of red and 6 minutes of the near infrared. So that's like 8 minutes. And we seen beautiful results, but she was under it for 3 minutes. And she said, I don't think it's doing anything. And she lifted the helmet up. I can't help that. You try taking, if you have a headache, try taking a quarter of an aspirin and see if it does anything for you. It may, but we have found that for migraines, we need at least that kind of 8 minutes of time. Some people start feeling it right away. Others, they need more time. And we even saw somebody that before they got the results, they really needed, or a significant, cleanup of what they were experiencing. They needed much more. So let's continue down. So, by the way, if you're trying to treat with the Palm device, you're going to have to try and figure out where is the best placement of the Palm device. It may be the temples, maybe across the frontal cortex. It may be all different areas of the. Oh, we are. Wow, I didn't realize we were at that time. But anyways, you may have to treat a lot of times before you figure out where the best placement treatment places are if you're using a Palm. And I have had people having success with getting rid of migraines with the Palm. So we're going. One final question here is: our devices are Class 2 registered medical devices. We just don't have. It's a wellness device. I'm not a medical doctor. I'm not, you know, trying to examine or whatever your situation. These are general things that we've seen feedback from other people. So great. I'm just going to scroll down very quickly. Let's have a look here. There's so many. Please send your questions to info@sunpowerled.com. That's info@sunpowerled.com. And a good question there, Bill, is it possible to treat too long? And really, we're not seeing a problem anywhere below the neckline. If you're going to be treating up in the face, I say, or the brain, and that you need to be a little more cautious. But we have not seen real issues with longer treatment, bigger dosages. Mary, if you want to send me an email, and it's really cool how we've been able to help so many people. So I want to thank everyone for joining us. This has been a super long one because we covered a lot of technical stuff. Yeah, please connect with us at info@SunPowerLED. And also, please remember, if you do want to get a palm light and you've been thinking about it, or a mini canopy, or a helmet, and we have HSA and FSA now on our website, so people can use their health savings account. You can also divide the payments over a year without interest through Affirm, or you can do it a lot longer. You can do it over 24 or 36 months, but there are then additional interest charges. So just call in tomorrow, and we'll be glad to look after you with your purchase. So thank you for joining us tonight. And remember, if you do make those purchases, it also helps us do even a better job. And we're looking at trying to get more trials going. We got one going for Alzheimer's, and we got another one going on for migraines. And we're hoping some other ones can come on as well. So thank you, everyone, for joining us. I wish you all of God's richest blessings. All the best for your week, and we'll see you next Tuesday. Bye for now.